Trigonometry explores relationships involving lengths and angles of triangles, and the important thing is that it really works well on the plane, which means for us that we need to be aware of the actual plane where we try to apply our calculations and making decisions regarding the actual math. So our application of trigonometry will be focusing on analyzing angles between vectors in space. As we begin measuring angles, we discover that a lot of times user input and display is shown in degrees, but internally the computations are performed in radians with respect to measuring angles. So why use radians? For us primarily because C++ library such as sine, cosine, and other trigonometrical functions accept angles in radians. And here's the formula to calculate the circumference of a circle, and it's of course 2 times radius times pi. So we really need the definition of pi, and we have a little bit of an example here. So we could possibly define pi as a C macro like this. I'm just going to copy and paste it right here, and let's go ahead and display it. Alright, so I'm just going to save the code, build it, just to make sure that my solution is ready to go, and press Ctrl F5 to run the program. So it runs and displays this value. So to be specific, this macro definition simply adds a macro to the preprocessor symbol table. So when preprocessor takes care of the source file, it simply replaces it with this. So of course this becomes double precision floating point number. The data type chosen for this output operator that connects this value with cout is a double type. So cout, the character output device, is programmed by default to display floating point numbers using 6 significant digits. As you can see that we have 3, 0.1, 4, 1, 5, and 9, altogether 6 digits, with the radix or floating point displayed here as well. If we want to increase precision, we can first switch over to the fixed output format, which will be focusing on displaying the current precision after the floating point. So if we compile this code and run it, you can see that precision increased a little bit, just a little bit, and now instead of showing 6 digits from here, now we're showing 6 digits after the floating point. So then we can also increase the precision by using this precision manipulator. Okay, so we can add this output as well. And this is supposed to increase the precision of the output to the highest value, which is precision 20. So let's build this code. And the errors that set precision requires an additional header. And this header is called IO manip for input-output manipulators like this. Alright, saving this. And so now you can see that our precision has increased to this strange looking value, which unfortunately not a true value of pi, but rather this is the result of compiler rounding this number and storing it in double floating point format. So it'd be nice if we could somehow obtain the entire pi of this precision directly from C++ standard library. And if you read documentation, what we can do is include CMath header, which defines mpi symbol, which represents the correct constant of pi. So I switched from my pi preprocessor define, and now I will just comment it out and start using mpi. And I get another error that tells me that mpi is undeclared identifier. So on some compilers, this header file will automatically include definition of pi and other fundamental constants, but on our compiler here it's not automatic. So if we read documentation for CMath, to be able to include these definitions, we have to say something like this: define useMath defines. Okay, so we'll save this version and try building again. And yet again you get undeclared identifier, so this may start sounding really confusing. Why is this not happening? And the reason is that apparently IOStream and IOManip already include CMath internally, so this does not have an effect. So unfortunately what we need to do is push this header to the top, and I believe this should solve our problem. So building it again, and this time it worked. So let's run this, Control F5, and you can see that this is now a much better version of pi output, and now we managed to our best ability on this platform and this specific compiler and using this specific type to obtain a pi value as we should. One of the latest C++ standards, C++ 2020, recommends that we use the numbers include, which should give us access to these two definitions: standard library namespace numbers pi, and that's by default a double, but there's also a template definition of pi for the shorter version of the floating point number, which is the float data type. So let's try this as well. Alright, and if I scroll to the top just to see what's happening, why is it not allowing me to print those two things? The error message that I get here is that the contents of numbers are available only with C++ 20 or later. So apparently my compiler version does not support this at this specific time. So I'm just going to remember this for future use, but not today. So I'll comment those things, just say C++ or later in the comment, so perhaps in the future we can start using this type of thing, but for now we have no chance but to comment it out, and that's the best version that we can get.